I know the semester is going good for me. I hope it is for everyone else. It's definitely coming by quick. We have spring break just around the corner, so today I want to help everyone get around that corner with style, with skid science. So today I'm going to be relating engineering to drifting. So let's get right into it. So first, for drifting, obviously you're going to need a car. So when you're picking out a car, there's just a couple things that you need to look at, and we're going to focus on the potential of the car, not the actual numbers of the car, because you're going to build your drift car. So these are the four most important criteria. These are the permanent things, stuff as a mechanic that you wouldn't want to have to replace or work on excessively. The most important one is going to be drivetrain. So when it comes to drivetrain, there's three main kinds of drivetrain that you're going to want to be familiar with. So we have front-wheel drive, rear-wheel drive, and all-wheel drive. When it comes to drifting, we really only have two options, which is going to be the rear-wheel drive and all-wheel drive. So the next thing you're going to have to worry about is going to be your weight, total weight of the vehicle, and your weight distribution. So the weight distribution comes down to your engine placement. So there's not a lot to talk about. It's pretty common that you're going to have a front-engine vehicle, so a slightly front bias weight differential or distribution. And your goal of your weight distribution is to be 50-50. So you have the center of rotation is going to be the center of your car, just to make it kind of consistent when you drive. Then you'll have rear engine vehicles, which are going to be a highly rear bias weight distribution. And this is considered the least desirable because having more weight in the rear end will allow your car to have momentum to throw that rear end out. But having more momentum will make it harder to recover from a drift. The next thing you're going to have to worry about is your ride height. So the ride height is going to determine your center of gravity of your vehicle. The higher your center of gravity, the more leverage the mass is going to have on the vehicle to roll when you come into a corner. And because you're drifting, you're going to have an excessive amount of body roll because all you really do is turn. So then the last criteria is going to be performance. And as a car guy, you're probably going to be upgrading your engine continuously, your whole car in general. So this isn't that important, but you have to worry about, like I said, the potential of the car. So I'm going to focus on minimum horsepower requirements. So two-wheel drive drifting, you're going to be looking at greater than 175 horsepower. And for all-wheel drive drifting, you're going to want greater than about 400 horsepower. Now, there's a lot of different things that will change how much horsepower you need. The main one we're all familiar with, the road conditions. So if it's snowy, you probably don't need 200, 300 horsepower. But weight would also make a difference, and power loss in your drivetrain. Okay, so now we can put this all together. So I just dug into the engineering toolbox, grabbed out one of the most basic tools, design decision matrix. So I threw together the four criteria we just talked about: drivetrain, weight distribution, ride height, and your performance potential. I ranked my car, two of my friends' cars, and some of the most popular drift cars, and you can see how they turned out. Focused on the drivetrain, I ranked each category out of 10. The drivetrain is twice as important as everything else, making the total score 50. Okay, so now we're going to focus on like your goals as an engineer for your drift car. From here on out, I want everyone to assume that we're talking about rear-wheel drive drifting only, not all-wheel drive drifting, just to simplify it. And then I want to clarify drift angle. So drift angle is just how we're going to measure how fat your drift is. So this is also referred to as slip angle, and it's going to be the difference between your front tires and your rear tires, or the difference between your direction of travel and your rear tires. And generally, you want this as large as possible. So you're going to want consistent handling. It doesn't matter if your handle is good or bad. As long as it's consistent, you can account for that. And you're going to want the maximum amount of grip. Now, grip, this seems kind of counterintuitive. Most people think that you don't want grip when it comes to drifting. That's the complete opposite of what you want. And I'll tell you why. So to split it up, you have grip in the front and grip in the rear. Grip in the front does two things. It's going to take some of the centripetal acceleration. So when you're coming around that corner and it's pulling your car outward, those front tires are going to keep your car from sliding outward. The second thing is the grip in the front is going to determine your entrance speed and your entrance angle. So having insufficient grip on your front tires, when you come into that corner, they're going to slip and cause understeer, which is where your front tires are going to kind of slide, break traction, and go through the corner rather than drift around the corner. And that's opposite of what we want. We want oversteer, which is where you're drifting. Next, we have grip at the rear wheels, and this is important for two reasons. The first one is your rear wheels are going to be sliding at an angle compared to your direction of travel. So we all know that this means that only a portion of the work being done by the rear wheels is going to be aiding or going in the direction of your travel. So it's important to compensate for that by having as much grip as possible. Secondly, the rear tires are spinning, obviously, quite fast, so we're dealing with kinetic friction rather than static friction. And we know from engineering principles that most of the time, maybe all the time, static friction is going to be higher. And since we have kinetic friction, we need to compensate for that by having additional grip. So the next thing that the rear tires are going to focus on are transferring some of that work towards the center of your rotation, which is going to pull you against centripetal acceleration and allow you to turn tighter and go faster around the corner. Both are good things. Okay, so now if we start focusing on more micro-scale tuning tips. When it comes to the front tires, narrow wheels will give you greater steering angles. And then it's important for tires, we all know, to run at their optimum tire pressure. So it's considered about 32 psi normally. To compensate for the heat that's generated when you drift, that's going to cause an increase in tire pressure. When you measure your tire before going out and drifting, so measuring it cold, you want to compensate for that heat by reducing it down to about 28 psi for the front tires. And the rear tires are going to be pretty much the same, except they're going to generate even more heat, so you compensate even further by going down to 25 psi. Obviously, as wide of a rear tire as possible, that will give you the maximum amount of grip that your car can handle. From here, we can start focusing on the suspension setup. So I simplified it down just to the two most basic levels. So we have camber. You can see the diagram on your right. It's going to be the top example. So this is the top of the tires coming in towards each other is going to be negative camber, and this is kind of iconic for drifting. They call it like a stanced vehicle. You see the front tires leaning way out. And what this is going to do is it brings us back to our center of gravity and having that body roll. So when you have body roll and it's so exaggerated in drifting, it gets transferred down into the tires and into the road through the suspension. So you compensate for that exaggerated body roll by putting negative camber so your lead tire will stay flat to the ground. Then you can move into toe. So toe is technically you would have parallel wheels, but this would bring the tips of them closer together if it's a negative degree value. So in the front, having negative toe will have your car, it will increase your car's stability or ability to go in a straight line. But having too much toe will actually just create excess drag and make your drift slower, make your steering less responsive. One thing that's really awesome I didn't know about was the rear toe. So having rear toe, you have positive toe, which will push your tires outward. And what this does is actually kind of steers your rear tire in the angle of your drift. So your lead tire is actually going in the direction of your corner, which will increase your drift angle. So our last major component is going to be your differential. So differentials, there's basically two different kinds. You have an open differential, which is the most standard on stock vehicles. And then you have like a limited slip differential, maybe a solid differential or solid axle. For drifting, you don't want open differential. An open differential is going to distribute the power to one wheel, and it's normally the wheel that has the least amount of resistance. And this goes back to the consistency in handling. This is inconsistent. It's not that you can't drift with an open differential, but it's harder to because you're not going to always know what tire is going to spin. So you want a limited slip differential or a welded differential so you can guarantee that both your tires are going to break loose at the same time and handle consistently. So that's that. I hope everyone has a great rest of the semester. Thank you everyone for listening to me.